Hello, Matt G4IYT here. Today we're looking at the full license mock examination number 1, version 1.6. We've reached question 42, which reads, a domestic VHF FM radio receiver is noticeably more sensitive to interference from a neighbour's HF transmitter when on the 3.5 MHz band than on other HF bands. This is likely to be due to A harmonic of the transmission getting into the receiver IF stages, B, the polar diagram of the amateur antenna having a lobe in the direction of the VHF radio, C, the house mains wiring being resonant at that frequency, or D, the dimensions of the receiver being such that direct pickup is more efficient. So we're told about these transmissions on the 3.5 MHz band or 80 meters, and we're experiencing interference on this domestic VHF FM radio receiver, and we need to figure out what the link is. So let's start from the bottom and work our way up. So option D, the dimensions of the receiver being such that direct pickup is more efficient. Well, remember we're talking about the 80 meter band. A domestic radio receiver is probably going to be physically very small compared to 80 meters, and so its dimensions would mean that it'd be an extremely inefficient antenna for 80 meters, and so it certainly can't be anything to do with the dimensions of that receiver. Option C, the house mains wiring being resonant at that frequency. Well, it's certainly possible to pick up radio transmissions on your house mains wiring, and it is also possible that your house was resonant on the 80 meter band. However, if that was the case, we'd probably be seeing issues with other devices, not just this VHF FM radio receiver. And being resonant on one band would also mean that it would probably be reasonable on other bands as well, and it only seems to be happening on the 80 meter band. It doesn't seem to be happening on the 40 meter band or the 20 meter band, as far as we're told. So we can probably rule out that answer. Option B, the polar diagram of the amateur antenna having a lobe in the direction of the VHF radio. Well, even the most directional antennas, if it's just over the fence in your neighbour's garden, you're going to be hearing something off the side of it, and that could be getting into your radio receiver. So it doesn't matter that the lobe is in the direction of the radio. It would certainly make any interference more powerful, but if there was going to be any interference, it probably wouldn't matter which direction that antenna was facing. And that also doesn't explain why the problem is unique to the 80 meter band. So that leaves us with the final option A harmonic of the transmission getting into the receiver IF stages. And if we look at the full license manual, it does actually mention, this is in the EMC section, about how FM broadcast receivers usually use a 10.7 MHz intermediate frequency. It does also comment this is susceptible to direct pickup from 10.1 MHz and from harmonics of 3.5 MHz. Well, let's just check that out. So if we were to take 3.5 MHz and times that by 2, that gives us 7 plus 3.5, that's 3 times 3.5, that gets us up to 10.5 megs, which is pretty close really to our intermediate frequency that our receiver may be using. So it's entirely possible that a harmonic from a transmission on the 3.5 MHz band could be getting into the receiver's IF stages and causing that interference. Perhaps that might be something that a low pass filter could help with, or maybe some extra shielding around that receiver could make a difference. Let's skip down to the answers, see if we got that one right. So for 42 we're selecting A, and for 42 you can see the answer is of course option A. Thank you very much. I'll catch you for the next one.